Okay, so we're looking at systems of equations. Technically, this is listed for Minnesota as an 8th grade standard, but it's really important. So I wanted to take and make sure that I touch on all three places one more time before you end up taking the MCAs during the spring, because it seems to, even though it's technically that 8th grade piece, it seems to pop up in those MCAs. And the concepts behind it, you work with a lot of things that we do anyway. So a little bit of background that we need. And, you know, I had aspirations that I was going to blank out certain things on the original to give to you, so that when you were doing this, you had to write some things in, and oops, I forgot to. So please make sure you're following along, adding any additional stuff as needed. So the linear model, just as a reminder, is y equals mx plus b. That's the y-intercept form. And that can be graphed on the graphing calculator. That's the format we want all of this stuff for our graphing calculators to work. When we get a little bit further in, I'll make sure that you grab your graphing calculator. You'll need it as you work through this stuff. This ax plus by equals c is standard form, and this is all things that we've gone over already this year. And it must be converted to that y equals in order to use on the graphing calculator. The standard form just gives a set way that you could identify a line, as long as A, B, and C do not have a fraction, and generally, well, and A is always positive. Right? And we've talked about that in the past. So what we're doing with that is we're saying we've got a systems of linear equations. That means we've got two lines. And we literally did some of this when we were looking at those word problems. We had to take the word problems, we graphed two lines, and we looked at where they intersected. We're just doing that with a little bit different without that word problem piece, but you've already done that a little bit this year. We're taking the linear equations and we're looking for the intersection. That's it. So when we have that systems of equations, we can either have one solution, no solution, or infinitely many solutions. Okay? If we have one solution, it means that they intersect in one point. If we have no solutions, it means that the lines are actually parallel. There's no solution. Because by definition, the solution is where the lines intersect. So do they intersect anywhere? No. So if they don't intersect, there can't be a solution. And I think one of the other slides shows you what happens if you're doing it by hand when we get those two. Infinitely many means that they're actually the same line. There's actually a line 1 and line 2 here. But they're just over each other. And so they're on top of each other. It means that everything is a solution. If I pick this point, thank you, it is on the line. If I pick an x at 3, it's on both lines. If I pick an x at -2, it's on both lines. There's not one answer, there's a multitude of answers. Okay? Okay, so in order to do this, we're going to focus heavily on the graphical, because your graphing calculators will do this. So another reason why we should be really good at manipulating that formula, ax plus by equals c. So we're going to be heavy on the graphical, but I will show you both the elimination and the substitution method. And it would make sense for you to try a few of them, and that's what our vocab will focus on, is doing it by hand in these two methods. And here's kind of like the overall cheat sheet of how to do these. So the graphical, you're going to graph both lines. And you're going to look for the intersection. Duh, we're done. Okay. The only difficult piece on this one is transferring that one equation or both equations to y equals mx plus b. If you can do that, you've got that one. Okay, elimination, and we'll walk through these. And there's other additional help videos built into this slide that if you want to go back and rewatch something else, there's other examples of them. Elimination, you're going to set up opposites. So if I have a 3x, I will set up a negative 3x, and I'll subtract that to the other side. In this one, we're actually adding equations together to eliminate. If I had 3x and I minus 3x, the x's go away. And that's what we want, eliminate. And hopefully some of this is coming back going, oh, I remember talking about this. Oh, I remember I hated this topic in 9th grade or 8th grade or whenever you did it. Okay. Then we're going to, like I said, we're going to set up opposites, and then we're going to add the equations because we're really taking 3x plus a negative 3x. We add equations to eliminate one variable, so then we'd be left with the, if this was 3x plus 5y equals 10, plus 7y equals 20, then we would literally add the two equations together, and we've eliminated the x's, and we would end up with 12y equals 30. So I just added everything up. And then I would substitute, because this I can find, and I just did this off the top of my head, so it didn't give me a really fun number, but this would mean y is equal to 15 over 6 if I reduced it down. So then now I've got the 1, I can substitute this 15 over 6 in as the y, and I can solve for the other one, solve for x. And we'll show you that as it comes up. Okay. I'm going to cruise through quickly on the elimination. We're going to focus more on the graphical. As we do the vocab piece, then we'll focus more on the paper pencil pieces. Okay. Substitution, and realistically, as we teach them in 9th grade, we usually teach them graphical and then substitution and then elimination. This is like level 1. Substitution is like a level 2. Elimination is like a level 3. Which is always funny for me because I always enjoyed the elimination method, although I did become a math teacher, so. Okay. Substitution, you solve one equation for a variable, you substitute and solve for the other variable, and then you substitute back in to get your last one. So it's all about, if I have y equals 3x plus 5, and I have a 4x plus 2y equals 17, I can take this whole piece and replace it into the y. And then we go from there. That's a quick overview of all three methods. Now we'll slow it down a little bit, and I'll show you where you can get to more videos if you need to, and so forth. Determining the number of solutions. Remember those solutions like we saw on that first page, we're either going to have one solution, 0 solutions, or infinite. Okay? I know, I'm sorry. Okay, so as we're looking at this, each A, B, and C is paired up with the two equations that make that. And then below it, in addition to actually having that correct number of solutions, this is the one that has infinite number of solutions. This one is parallel. This has 0 solutions or no solutions. And this one has just the 1 solution. And just because of vocabulary, mathematics, we tend to try to be as confusing and specific as possible, right? And then call ourselves logical. They're going to give these names. So if we have a solution, which is this A and the C, it's said to be consistent. So these two are consistent. A and C are consistent systems. They have an answer. If I don't have an answer, that system is said to be inconsistent. Does that make sense? You don't have an answer, it's inconsistent. It doesn't work. Then with the consistent ones, they gave it one additional name. So this is dependent. And if we think about that, it's dependent because the answer depends on which x I pick. If I pick x as a 2, I would get the dot I just made purple. If I pick x as 4, I get the dot I just made red. If I pick x as -2, I get the dot I just made blue. See how the answer depends on what I pick. And there is always an answer. As opposed to this tends to be, when there's one solution, that tends to be the one we focus on most. We just throw the other two in there, but there's an infinite amount of all of these different types of options. If there's one point, exactly one solution, we call that independent. Because it doesn't matter. I can't pick any point. I must pick exactly one x to make it a solution. It's exactly the x, y. Any other question there? Okay. Now, in here, I used some of the slides from the previous year when I was doing this in the more traditional method. And as I went back to the slides, I found all these handy dandy videos that I had made. So I left the videos on there. So if you go into this slide and you want to see more about this, you can click the link and watch all of these videos that are in here are between 2 to 7 minutes. But that would give you additional information if you needed to. Okay, solving graphically. Here's where we're just going to plot them in their graphing calculators. So I'll give you a moment. Go grab your graphing calculator. All right, so most everybody should have their graphing calculator. Now this first piece, when they give you the graph already, people, they did the hard work for you. This first piece, this first one that'll be in the delta that I'm not, I told you to go get your graphing calculators, but this first one you don't even need it for. And you'll have, I think I gave you 5 of these, because they literally should take it 15 seconds apiece. You'll look at this. Here's this equation. It was graphed, this steep slope going with a negative slope. The other graph is the 1/3 x plus 7. That's a positive. We're looking for the intersecting point. Where is the intersecting point? -3,6. Yeah, that's the answer. That's done. Not bad? Okay. Now we get into a little bit more. So now, if they don't give you the graph, then we've got to take and do a little bit more work. We're going to use the calculator to get the final answer, or if you just graph them on that piece, you should be able to find it. But I do want you to make sure that you can rearrange it because it's much easier to graph that way. So this first one we'll graph in the purple. And I'm going to graph this line by hand, and then we'll talk about that calculator piece. So if I graph this one by hand, reminder, I go up to the 5, and I put my dot, because that's a y equals mx plus b. And then from that dot, I'm going to move my slope with it, which is the -1/3. So I'm going to go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. On delta, you just have to put it in 2 lines and then click it. It'll make itself the line. Okay. Now the second line, we'll do this one in purple or in blue. I have to get this into the y equals mx plus b form for the calculator, for my by hand drawing any of the different items. So in order to move that, and we've practiced this many different times, I'm going to minus 3x on both sides, and then I'm left with negative 2y is equal to 12 minus 3x. And then I'm going to divide by the negative 2. And you want to make sure that if there's a negative sign, you're remembering to divide by the negative sign. Otherwise, you'll mix the sign of the line up. It'll be going the wrong direction, and then you won't be getting it right. Now, for this, if I'm putting it in the graphing calculator, I can put it in the graphing calculator right like that, doing a fraction with all of that. If I was doing this on the paper and getting it onto the delta, I might want it to look more in that y equals mx plus b form, which means I'm going to divide that direction and this direction. The negative 2 divides both of them. So that'll give me y equals negative 6. That was a 12 divided by negative 2. And then negative 3 divided by negative 2 becomes a positive 3 over 2. We want the fraction, we don't want the decimal, x. There I've got my y equals mx plus b. From there, I can graph that line. I start at a negative 6. I'm going to go up 3 over 2. And I would repeat that process twice. Well, just the one time you should be able to snap the line on delta. For this one, I want to repeat it until most likely those two lines, when you do it a few times, will intersect, which is what they did. That intersection is my answer. And that on here is 6, 3. So realistically, none of what we've done is new. You've been doing all of those different steps. We're just putting them all together same time. Now, as you do it on the calculator, in the next slide, I'll walk through that in a little bit more detail and show you example. You're going to use the calculator. You place them both in on y1, y2. Do the draw. When you get into the y equals mx plus b form, you must see the intersection, and you can do a zoom auto, you could do a standard, or you can just use the arrows to move it up and down. But you must see the intersection. Once you see the intersection, you press a G solve, which is F5. Then you press intersect, which I think is the same, F5. And then there's the answer. It'll say x equals 6, y equals 3. And this one, why don't you give a try right now for this method? Here's the two equations they gave you. The bottom one, y equals 5 plus x, looks great. I put that in for y1 because it was so easy. It was already done for me. The secondary one I've got to change, so I take my 2x on a piece of paper, and I'm going to minus the 2x. So I've got 2y equals 10 minus 2x, divide by 2, and that gives me my second equation. Type those both in. That was that graphing solve. We entered it. Make sure you're using that X button, my Zot button. Don't put any other X in there. Then you're going to go to draw, and you can press the zoom auto. And see, this is what I mean by see the intersection. I've got to be able to see where those two lines cross. Thank you. When I see where those two lines cross, then I can go for that G solve. Remember that algebraic wrapper? Come on, people. Okay, and then press intersect, and it's showing intersect is at 0, 5. Give you a minute. Make sure you get that, and then I'll start back up. Solving by substitution, we'll get through this part. The elimination will probably have to work tomorrow. So it does make sense. You'll need a little extra time in this section. Substitution. So here are the steps for the substitution. And as before, there's a little video link down in these slides. So you could watch me walk all the way through this substitution piece. Now, as you're doing these in Delta, or if you were doing these on the MCA, and it just wanted an answer, it doesn't really care how you solve them. So if you want to go ahead and do this, the graphing calculator again, you can. That's why you should be really good about rotating that around and solving for y. With the substitution itself, we have to solve one equation for a variable. There's 3 steps. Then we substitute the expression that we got into the other, and then we substitute in again to get the answer. So the first thing we look at is which of the 2 equations, and it's an opinion. It'll work out either way. Which of the 2 equations looks easier, the top or the bottom? This would be the top one, this would be the bottom one. Which one looks easier? Top? I would say top because it doesn't have the coefficients. Doesn't have the numbers in front of x, in front of y. So then I have to pick. Do I want to solve for an x or do I want to solve for a y? Doesn't matter. What do we want to do? Y? Awesome. Okay, so we're going to solve the top for y. To solve it for y, I have to minus the x from both sides. So I get y equals 3 minus x. Done with the first step. All things you could do. In fact, you'd have to do that if you were doing the graphical anyway. So now in substitution, I'm going to take that handy-dandy equation, that box that I made, and I'm going to stick that 3 minus x into the y. And that is doing substituting the expression from step 1 into the other equation. And then I'm going to solve it. So now I've got, and I'll switch to blue, I've got 2x plus 4 times that whole 3 minus x is equal to 8. Now you use your algebraic skills that we've been working on, and I've seen this whole last trimester, that we're going to distribute the 4. So I've got 2x plus 12 minus 4x equals 8. Then I'm going to combine the 2 x's, so I get 12 minus 2x equals 8. Now minus the 12. And I have 2x is negative 4. So x is, dividing both sides by negative 2, I end up with x is a positive 2. I've got half of my answer. So then I take that half answer and go back up to that substitution to get the last part. So it says substitute the value from step 2 into one of the originals. And so all I have to do, and I'll do it on top in red, well, I'll do it in the bottom here. 3 minus x was equal to y, so I put that x in there as a 2. 3 minus 2 is equal to 1. So that y is equal to 1. So now I've got my point. My actual answer was the 2, 1. It's both these answers at that same time, the x and the y. Make sure you write them in the correct format. Don't, 1, 2 would be wrong. It's got to be that x comes first, y comes second for my point. Questions there? Now, you'll have some of the videos on Delta. In addition, if you needed and wanted to watch an additional video, that substitution video talks you through that whole thing also. I think I'll walk through this one last problem here with the substitution, and then we'll be good to go for today. And we'll continue that last three or four slides tomorrow. So substitution. Hey, I've already got an x equals. So my first step's done for me. So now I need to take this 9y and stick it in where the x was. That gives me a negative 4 parentheses 9y, we're just filling it in the box, plus another y is equal to negative 35. We're just solving for that y. Multiply the negative 4 and the 9, I get a negative 36. Y plus y equals negative 35. Combine like terms, I get a negative 35y equals negative 35. Divide. Y equals 1. I'm done with that step 2. Step 3, I'm going to take this and go back up to that equation. And that will give me x is equal to 9y. And I know my y is 1, so x equals 9 times 1. X equals 9. So my answer gives me 9 comma 1, along with putting the parentheses around it. On paper, you need the parentheses to make sure you're writing a point. On Delta, they kind of give you the parentheses already. Okay. Questions on any of what I've gone through? So we went through graphical, we went through the vocab, we went through substitution. All we have left is elimination, but you could start, if you really want to get going on it, you could start Delta at any time. Thank you, people.